Warm welcome from my side. My name is Andreas Macher. I'm a product manager for redundant PLCs at the Siemens AG. Yeah, in the next minutes, I want to give you a brief overview about the OPC UA redundancy. So it's not a deep dive, it's more a general talk about high availability and how the OPC redundancy relates to. So first of all, what's high availability and what is the motivation for this? So in industrial automation, there are several applications which require continuously operation without any downtime. So high availability is then required from a customer point of view to, for example, prevent plant downtimes, which costs money because there's a loss of production. Another industry for high availability applications is, for example, in the gas productions. But where is OPC really required is in infrastructure projects. For example, in tunnel automation, OPC is becoming the de facto standard for communication. And because also here there are redundant applications needed, so this redundancy topic of OPC8 becomes very interesting. Yeah, how to come to a high availability application. So there are many things to create a robust and durable application, but the one very common used technology is to have redundancy. So this is, let's say, very often used. And the OPC definition is very simple. It's the presence of duplicate components which are enabling to continue the operation after a failure of an OPCIA component. So we're talking about failures, and we're talking about what happens if something goes wrong. So let's think about the different types of redundancy. So when we took a look into the specification, there is the server redundancy, where the clients then have multiple sources to get the data. Another concept is the client redundancy. So there are more different clients which are identically configured. So if one client fails, there is another one which can take over the job. And there is the network redundancy, which allows a client in the server to have multiple connection paths to get to the data. Yeah, in the picture below, there is just an example how this could be combined. Of course, client redundancy, I think, is often used because typically more clients than servers are used. Server redundancy is what we are now talking about in the next slides. But of course, you can combine all of this, and let's say full redundancy is then to have redundant clients, redundant networks, and also redundant servers. Yeah, so let's focus on this server type. So to have multiple servers to provide the data, and to make it more concrete, and a little advertising. So this is how Siemens realized this server redundancy in its PLCs. So these are the so-called 1500 R&H controllers, which are working synchronously, or working on the same program. If one controller fails, the other takes over the job. And with the beginning of the year, also OPC UA server is included. And also the OPC UA redundancy now works within this PLCs. So let's take a look on the defined failover modes for server redundancy. The first one is the so-called cold mode. In this case, there is only one server active. And the second one is there, but it's powered off. So if you have a failover, you have to start the second server, which will take, of course, a time. So it's not bumpless. It will take some seconds or minutes to get to a running system. The next step is called warm redundancy. And in the warm redundancy, there is already a server active, but the server has no connection to the data points. So only one server is sending data, but the second server is there. To get it running, the server has to get the data from the PC in this case. And this is of course faster than the cold. Then the next step is the so-called hot redundancy. So in this redundancy, both servers are sending data to the client, and it's up to the client to select which data to get. Yeah, and the last version is called hot plus mirrored. In this case, although the two servers are here, but they are synchronized, so they're having the same data. So the client can immediately switch to a backup server in case of a failover, and will find the same data from the second backup server. Yeah, let's talk about the hot mode and the hot plus mirrored mode. So the hot redundancy mode is initiated by the OPCDI client. In this case, both servers are sending the same data. The client has to decide which data to use. The big advantage of this is if there is a failover, then there is no bump. Bump means there is no data loss. There is no break in the data stream because always both data streams are there. And yeah, it's just the client to select the working OPCDI server. Disadvantage is, of course, to have a double network load because the servers are sending both of the data. And second disadvantage is that from the server side, you need both power, double power, so you will not have so many OPCDI items as in the next mode, in this so-called hot plus mirrored. So in this case, only one server is sending data, second one is ready. So it's optimally utilization of the network capability. Also here there's a fast switch over because the second server is ready, but it's not completely bumpless because there is a short time of failover, and then the second server is ready. Yeah, there's another term in the specification which is called transparent and non-transparent redundancy. So first about the transparent redundancy. So in this case, the OPCDI client always connects to the same endpoint URL. So from client perspective, it's transparent if there is a single or a redundant system. When there is a failover, the server has to manage it. So it has to make sure that the endpoint is there also on the backup server. So from client point of view, a failover is just a short interrupt in communication, and then it finds again the same server. And so it's made for all the clients which are not aware that there's a redundant system below. Yeah, the second type is called non-transparent redundancy. In this case, it's up to the client to select the appropriate server. So there are two endpoints for each server. And yeah, the OPCDI client must have the capability to find out which is the better one or which is the working one. Yeah, this is not so often used. So typically the clients will use the transparent redundancy. But for the question to find out which now is the better server or the server which provides the data, we realized this in the system using the so-called service level. You can see here the information model. So the client can read out the service level and we'll find the primary controller, so the one which controls the process with a higher service level than the backup PLC. And it will also find out if there is maybe a PLC not working at all. So the OPC server maybe is working, but not the PLC. So then the service level will be very low. In this case, it's done 0. It's no data. Yeah, so that's all about redundancy from my side. So thanks a lot. And I will leave back then to Stefan.